Hello, my name is Maurice Cherian and I will be your presenter today. Thank you for joining us for what's new in SOLIDWORKS 2011 for routing and for CircuitWorks. On the routing side, we'll be going over piping and electrical routes. So we'll go ahead and get started. Once again, thank you for joining us. And my name is Maurice Cherian. So I'll first go over the agenda. So I'm going to start with routes with routing on the electrical side. And then I will go into routing for what's new on piping. There are some things that are generic or work for both, and we'll go over that. And then we'll wrap up the webinar or webcast with CircuitWorks. So I'll go ahead and get started now. The first thing I'm going to go over is what's new in electrical routing. The first thing that you'll notice when I first bring up the settings for electrical routing and for piping routing is that the routing library manager has taken has had some big changes, a big facelift. It now has a standalone application with an updated interface to be able to go over routing location, making component wizards, making the component wizard to work a little bit better. So the interface has changed dramatically. I'll show you that. Another thing I'm going to show you is isolate. The isolate command now has where it can isolate the route only, the route in primary references, secondary references, and this isolating of the route can be saved as display states too. So we'll go into that, and then I'm also going to show you the improved stability of ribbon cables. Some people might have tried this in the past and maybe didn't have such good results, but now the flexible route's working pretty well. You can do some modifications with that. So I'm going to show you that, and some of that you might have tried before, and now you can see it working a little bit better now. So let's go ahead and get started. So the first thing I'm going to show you is the new routing library manager, and that has been improved dramatically. It has had a facelift. The interface is now a little bit more user-friendly. It's been consolidated, so I think you're going to like this. It does apply for electrical and piping routes. So I'm going to start by showing you that. Now the new routing library manager can be accessed in two ways. I can either click on routing tools, and here's the routing library manager. That would be one way to bring it up. And here it is. The other way I can bring it up is through what you might be used to seeing, where the display of the locations are. So under here, under routing tools, here's the first way. Now if I go to tools options, here's the other way to get to it. So you have to have routing turned on. Here's some of the routing settings, and I'll go over some of these here in a few minutes. One that I'll note out right now, or I'll note now, is the automatic route on drop of flanges and connectors, automatic route on drop of clips. So those are two you'll see here in a little bit. Now here's routing file locations. Now normally in 2009 and 10 and in other past releases, you would have the file locations here. But now it actually has this ability to launch the routing library manager. So this is going to apply to both piping and electrical routes. So here's a routing component wizard, and I'm going to show you some of these here in a second. So there's a component wizard, here's the cable library wizard, component library, covering, and then here's what you're used to seeing for the different settings here for, in this case, the electrical, where the electrical stuff is at for, in this case, the cable wires, components, standard cables. Here's routing, here's for the piping and tubing. You can actually load some settings too here if you wanted to. So I can load some of these settings up and save those settings. I can save them here. So the other two that have been added is this one with that works with the piping and instrumentation data, and this is where you can add more components that are going to tie to your XML data coming from the P and I and D diagrams and that information. So you have the tag scheme, and you have also this database that you can tie your, in this case, tags to the different files that are already located here, and you'll be actually able to get to the path for the files that are already located in the library. You can add more. So what I'm going to start with today is I'm going to show you how, in this case, to use some of the functionality of the component wizard. So what they have done for some of these wizards is, this case for the component wizard, I'll show you electrical. I'm going to go ahead and show you a clip, but here's how you'd make a connector. And some of this hasn't changed that much, but you will see that some of them have some drop downs here. So they've added some things for ribbon cables. They've added some for connectors. If I go back, this is something they have dramatically changed for on the piping and tubing side. They've added things like OLEDs and hangers and gaskets, and you can also see when you go into these, you'll see that they have some other drop downs. Here's coupling and filter strainers, other fittings in here. So they've actually added a lot to this. This one actually is generic for, in this case, piping and tubing. So I'm going to go ahead and start by showing you, in this case, an electrical component being turned from just an average part to, in this case, a clip or a connector. I'll show you a clip right now. So what this wizard is going to do is it's going to step me through this, and some of this functionality was in 2009 and 10, but what they've done is they've cleaned up the interface a lot to try to make it a little bit faster, so you can populate your component library faster. So the first thing I'm going to show you is, and on the electrical side, is how to add what was just a generic model that's a clip and make it actually work in the routing library as a clip that I can route through. So you can see I can pick clip, and now you'll see I can add points. I need to add, in this case, 2 points. And so I'm going to go ahead and click on add, and it's going to ask me in this case, and now I can close this out. Now you can see it's asking me to define the route points. Now in this case, I'll show you this where you can see this a little bit better. You can see there's a couple points, so this has already been set up for me. So that's where the route is going to go through. It's going to come in, and there's going to be a route axis, and it's going to go through the spline. It's going to attach here, and then it's going to have a straight axis, and then it's going to go through the spline is going to reattach on this side. So I'm going to go ahead and pick one of the points, and I'm going to go ahead and say OK. And what it's going to do is the wizard is going to come back up, and it has defined one of the points. Now it wants me to add another one, so I'll go ahead and say add, and now I can go ahead and select the second one. And now you can see it has been edited, and you can see if it's green, that means it's been required, and now it's been satisfied, because now you can see it's green and not red anymore. So I'll go ahead and select next here. It's going to step me through. Now the next thing it needs to know is how to run the wire, which direction is the wire going to run through. In this case, the wire cable is going to run through the clip axis over here where my mouse is. And then the axis of rotation is where you use the shift arrows to rotate this, usually in this case 15 degrees. So I'm going to go ahead and select add for the clip axis. And now it's going to ask me and prompt me, do you want to select a new one? Do you want to create a new one or existing one? I'm going to go ahead and say select, in this case, a new one. And now here's my clip. And now I'm going to go ahead and, in this case, I'll pick cylindrical conical face. You can see it put me into the reference geometry axis property manager. So the dialog box popped up on its own. I didn't select that. So I'm going to go ahead and pick the cylindrical face. And you can see now the axis. I could have used the points here to get it to go through here. So here's my axis. I'll go ahead and select the green checkbox to accept that. The wizard comes back up. And now it does have one here where you can add a second clip axis. It does tell me that some of these clips have dual, in this case, dual axis to run, multiple sets of wires or cables through here. So I don't need to add that blue one. That means, and blue means it's optional. So I'll go to the next one. I'll go to add the axis of rotation. That's going to help me to be able to spin this using the shift arrow buttons, which are very convenient. And I'll show you how that works here once we finish up making this component. I'm going to select add. I'm going to go ahead and say new. And now the axis of rotation, is going to be, in this case, the intersection of two planes. So now I'm going to go ahead and pick the right plane and the front plane, and now you'll see that's where the axis of rotation is going to be, and it's the intersection of two planes is how I'm creating this axis. I'll go ahead and say OK, and now you can see that the green means it's been satisfied. I can go ahead and select next, and now it's going to step me through. It's going to ask me to bring in some mate references. The mate references make your components, in this case a clip or a connector, make it snap to a face, or on a connector make it snap to the other connector on the other side, so that you don't have to put your own mates in there, which definitely speeds up time. In this case I'm going to add one mate reference. On some components you can add 2 or 3 or even more. So I'm going to go ahead and select add. This is an optional thing, but I would definitely put it in as much as you can. And so in this case, I'm going to get rid of the pre-selected one. I'm going to pick this flat bottom face, and so at least gives me one mate reference. So I'm going to go ahead and say coincident, and I'll pick, in this case, anti-aligned, which means that this face will snap to maybe a sheet metal face or another face, and not be lined up with it. It'll be actually opposite. That's what the anti-align means. So that's what I'll do. I'm going to go ahead and just make one mate reference. If I had some circular edges, those help a lot with clips and connectors. So I'm going to go ahead and say OK. Now it says I can go ahead and select and add more, but I'll go ahead and just select next and keep going. Now it's going to step me through one by one down the line here. So starting from the top going to the bottom, it just verified that in this case is nothing missing, so I can go ahead and select next. And now what it's going to want to do is it's going to want me to keep going. I can add, in this case I can open up a design table. This component, this clip does have a design table with a few configs in here, and so I can add more things like the manufacturer. So this is actually your custom properties or your file properties. So I can go ahead and put in a vendor here. So these will actually add custom file properties to your model here. So I'll go ahead and say next, and I can fill all this out, but I'll go ahead and move on. So here's next. Now it's going to ask me, where do I want to put this? Do I want to save it to a specific location? I'll go ahead and accept the default. So here it's an adhesive back clip. I'll go ahead and finish. Yes. So you can see it saved it. Now what it did in the background is, let's go ahead and take a look at the component. In this case it's a clip, and you can see here it says it's the clip axis, and then axis 2 over here is the axis of rotation. And there was a question, I did just check, there was a question on, can you use the same sketch for the route points? So here's the two route points. I'll zoom in so you can see it. Someone asked if you can use the same sketch to put your route points on. In this case, if you had a plane that was cutting through here, so I do have a plane, the top plane, so I could have put the points on there and put it on with one sketch. So that's up to you. In this case, these were on two separate sketches. I'll zoom in again so you can see that. So there was two different sketches for the 2 points, and ended up being the 2 route points. So again, what's going to happen is the spline's going to go through here, through the axis, and then the spline's going to come back out the other side. And again, the long axis where my mouse is, that's going to be the axis of rotation where the shift arrows will go through. So this part's ready to go. If I wanted to know where I put it, it is under routing, and here's electrical, and here's the component that I just created. So I'm going to go ahead and close this out, and now I have a test assembly, and I'll move this out of the way so we can see this a little bit better. Now I did set a couple settings up. one of the settings I did set was under Tools, Options, under Routing. I did select on the top automatically route on drop of flanges and connectors, so it works for both piping and electrical routes, and then also automatically route on drop of clips. So you'll see that one in action. You can save routes externally, or you can save them internally or in context, which will live inside the assembly until you're ready to save them out externally. So I'm going to go ahead and say OK here. Alright, so here's my test assembly, so we can see this in action. So what I'm going to do is I'm going to start my route, and I just showed you the options to start the route. So I'm going to go ahead and pick this connector, and I'll zoom in real tight so you can see it. And I use the library, and I had already created this clip. So here's my test assembly. I'll zoom in. So now we can try out what I did. I had already created a connector by using the routing wizard, or the routing component library wizard. So I'm going to go ahead and select that. I'm going to bring that in, and there are some mate references here. Now when I first start, you can see where the connector is going to come out, and this is going to be an external assembly, and you can see here's my different types: harness or cable and wire. And so I'm going to go ahead and say OK and start this, and you'll see once I accept it, you'll see that the route is started now. Now I'm going to go ahead and add my new clip that I just created. I'm going to zoom in over here so you can see it, and this has a mate reference now, and so you'll see that it'll let me put it in here, and if I hold shift and the arrows, then I can place it, and you'll see once I place it, you'll see the route start right away because I said automatically route on drop of clips. So there's one of them. Now I'm going to go ahead and keep going. I'm going to add another one, and again this has a mate reference. So here's the mate reference, and again I'm going to use shift arrow to get that in there. So I'm using the shift and the left and right arrows to locate this, and you can see that I do have one mate per clip, and you can see it's now routing through there. Now you can see that now the next thing I want to do is I'll route this through the rest of the way. I didn't put that connector over here, so I'll go ahead and add the other connector. And I'll zoom in. I'm going to add this connector over here. And now the final thing is I'll connect it from this point with the auto route turned on over to here, and now the route is done. I'll go ahead and say OK, and now you can see how the route is going. I'll move some of the stuff out of the way so you can see this better. I'm going to go ahead and close out of the sketch. I'm editing a 3D sketch, and so now I'm still editing the assembly, and how I know that is because you can see it's in blue over here. It says on the bottom I'm editing, in this case the assembly, it's a sub-assembly, and now you can see it says edit component over here. Now what I can do is, since I'm editing this assembly, I can move these clips around, and you can see that they're interactive. Now the last thing you want to do is you want to make sure that you fully mate this up. So in this case I only have one mate, so I'll do a distance mate from here to maybe the top, and then maybe I'll do the same thing over here, and I'll let it slide back and forth side to side. Okay. Alright, so now I still have the ability to move these around because I didn't fully mate them all the way. But you can see now that these are able to move. And you remember I had the axis of rotation there set, so you can move those around. Now one of the things I wanted to show you, and I'll move these windows out of the way here so we can see this better, is there's something called isolate now. Let me go back to the slides. Let me go back. Let me go back to the slides. So one of the things that's new for 2011 is when you hit the isolate command or select the isolate command. So one of the things that's new for electrical routing is, and this is generic, this works on electrical and piping, is the ability to isolate different things. You just isolate it right from the feature tree, and you'll see here you have different options. You have route only, route and direct references, route and secondary references, route bounding box, and then route segments bounding box. So I'll show you some of these. This one that's shown here is just the route only. So let me go ahead and show you that on the actual model, the actual assembly. So I'll move this over. So I'm going to go ahead and select isolate, and I'm isolating. In this case, I'm selecting right on the subassembly, the harness subassembly, and you'll see now it isolates it, and now you can see it's showing, in this case, the route only. And now here's some of the new functionality: route and direct references. Now you can see now here it's showing that connector that it's tying to, the piece that it's connecting to, and that's going to be the route and direct reference. Here's route and secondary references, and now you can see some of the fans are coming back and some of the other clips. And then here's route bounding box. So, and what's the bounding box? If I move my mouse over and hover over the actual harness and the feature tree, I'm not touching anything. You can see that orange box. That's the bounding box. So that's what that is. And then there's route segment bounding box. Now in this case, I don't have other segments, so you won't see that real well here. But you can see here's route bounding box. You can see here's route and secondary references. Now what they did is they put this save button here, so I can save this as a display state. So this one is route and secondary references, and so maybe I'll just do the route and direct references. So now you can see what it looks like. I can save this as a display state, route and direct refs. So I can name it whatever I like. I'll go ahead and say OK. I'll exit out of the isolate. Now where this shows up at is under, in this case, under the configuration manager. Here's the display state I just created. Here's the default display state. I also open up the display state from the customized commands, so I can show you this right up here without having to be in the configuration manager, so you can see how that works. Okay, that's going to complete these two steps. Now I'm going to go ahead and show you how to use, in this case, now I'm going to show you how to use the flexible routes for, in this case, a ribbon cable. Show you that improved stability. So I'll show you that next, and I'll try to show you both of these routes. Both types of routes for ribbon cables, both flexible, which I'm showing here, and also one called folded. I'm going to go ahead and show you both of these if time allows here. I'll go back over to SOLIDWORks, and I just brought up the assembly. Here's the assembly, and we were just showing display states. So again, display states show up here under the configuration manager. So I have one here that shows no sheet metal. Some of you might have customized your menus in the past, and here's one that might be helpful to show display states better. Under customize, here's one for display states. That's the one I put up there, so that's a good one. So I can toggle it without having to go to the configuration manager, so I can keep the tree up. So that's something that some of you might want to try out. So I'll go ahead and turn off the sheet metal enclosure around here, and I'll try to move this over a little bit so we get more of the graphics area here. I'm going to go ahead and route from this connector over to this hard drive over here. And ribbon cables are for use on hard drives or any other peripheral devices on computers, and there's some other applications of ribbon cables. So the first thing I'll do is I'll go into my options, and let's take a look at my options in this case for routing. I'll go into the routing library wizard here, the library manager, and I can set up, in this case I can set things like loading settings. I'll set the settings for ribbon cables, and I can save these settings down here. I think I had mentioned that before. So here's my settings. I can save it, and I'll go ahead and close this out now. Now the next thing I'm going to do is I'm going to go over to the routing design library, and here under electrical, this one's a little bit buried. There is going to be, and I'll try to move this up a little bit, there's going to be the connector I made earlier, or the clip I made earlier. Here's some connectors, and on the bottom of this list, kind of buried in the bottom, is ribbon cables. It does have clips, connectors, and sockets. So here's the connectors. Now the one I'm going to be using is this 3DPS here, 836. So I'll zoom in so you can see this. These do have some mate references. Sometimes they have more than 3, sometimes they have up to 6 to make this look real nice and snap right into place. On the mate references, sometimes we actually use datum planes or planes to help us with this. I'm going to go ahead and drop that in, and you'll remember that there are some settings that start a route right on the drop of a connector or a flange on piping routes. So here you can see it. Here's my routing subassembly. Here the type is ribbon, and so once I select the green checkbox and select OK, you'll see now it's going to create, in this case looks like almost like a center line here, and then this is going to be something that I can use to drag this route. Now you can see there are 2 selections here, and I'll go slow here so you guys can see this. There's folded and flexible. So I'm going to show you a folded one first, and so we'll keep that option there, folded. I'm going to go ahead and select, and I'll zoom in so you can see this. I'm going to bring in that same connector again and drop it over here, and now you can see now it has that center line, and it has the center line here that drags. I can drag this. Now I only have a couple of options with the ribbon cables. I can't go in and make 3D geometry. I can't draw my own lines and just freeform this, because it'll have trouble with kinking up of the cable itself. So what it does is it gives you almost like an orthogonal type of route, like if you were doing piping or tubing. So I'll pick the 2 endpoints, and here's what it's going to give me. It's going to give me, in this case, multiple options. In the multiple options here, I'll toggle through them all. There might be 3, maybe 4 different route types or route solutions. So you can see I'm just toggling the alternate path, just like a piping or tubing route. So you can see the different options here. So I'm going to go ahead and select that one. And now one thing I can do is some of these routes will have these arrows that I can flip, and that's going to flip the direction of which way the fold is going to go. So let me show you that again. So you can see here the fold, how it moves it. And if you want to, I can always turn off the sketcher relation so you can see that a little bit better. So now you can see how that affects the folded solution. So I'm going to go ahead and say OK, and now it's going to give me a message, and you might think there's a problem, but what it's telling me is that auto route is going to close out of the sketch. It's going to close out of the 3D sketch because you can't freeform and just make your own lines and drag stuff around. I can drag those connector start points or the connector stubs, and now you can see what the route looks like. I'll turn off the sketches here so you can see it with those removed. So you can see what the folded option looks like. Now that was already working pretty good, but what happened is now they had, I'm going to suppress this one. Now what has happened is now the flexible routes are working a lot better, and so I'll show you 2 examples of that. So I'll put the same connector in there, same spot, and I'll pick up here too. And there it goes. Okay, and I can drag these around a little bit if I go to the edit drag. So I can move these around a little bit. It does let me do that, but as far as drawing the lines, again, you're not going to be able to do that. So once I go to auto route, I'm going to go and select, instead of folded, I'm going to select flexible. And now I'm just going to pick the same things. I'm going to pick these middle points, and you'll see it'll connect it up. And now the folded had the sharp folds. Flexible has where it twisted around and doesn't kink it up. I'm going to go ahead and select OK, and again it's just telling me it's going to get out of the 3D sketch. So you can see the route, what it looks like there. It does twist it along. It's almost like a sweep, in this case a rectangular type of sweep. And now I'll go back and I will edit the route, and when I edit the route, now here's where I can go and say edit drag, and now all of the intermediate ones, this first one I can't move, but 1, 2, 3, 4, these 4 here I can move, and this is what wasn't working so well before. Now it's working pretty well. Now I won't push my luck, I'll just move it around a little bit so you can see me changing the geometry, in this case how it's twisting around. And I would say just move it a little bit, maybe try a little bit at a time and see if you can do it without it kinking. And now you'll see what it looks like when it's done. So you can see I moved how it folded around. I'll show you that same flexible route over here with the in this case with a clip in here too. It has this ribbon cable axis here. Now that I got that first flexible route in there, now I'll go ahead and add the second one. So I'll go ahead and add a connector here. And once I select the route type, I'll go ahead and put another connector down here on the bottom. And now I can do the auto route, and I can route it from here to through the clip, and then I can go from the clip axes to the end of the connector here. And I'll go ahead and select OK. And there it is. This one, you can see it's pretty close to kinking up, so I wouldn't really move that one around too much. You can see that it's almost half folded and half flexible here, so it does run through the clip pretty well. So what I'll show you before we finish up is again the display states. The isolate. So I'm going to isolate this one component. In this case, I'm isolating the subassembly. So I'm isolating the subassembly, and you can see here again are the different options. Route and direct references. So it shows the connectors that I'm connecting to. Here's the route and the secondary references, which in this case aren't really showing much. Here's the route and the bounding box. It's asking me to open up and show the rest of the assembly, and then here's route segments bounding box. So here you can see this one is isolating a little bit more of it. This one's not really showing as well. So there's a route only. Here's a route and direct references, route bounding box, route segment bounding box. So you can see some of these. I think the one that's showing the best here is this route and direct references. Alright, so again, all you do is just exit isolate. You can save those as display states. Alright, that's going to complete the electrical side of the routing of what's new. Now the next step is going to be to show you the piping side of things. So I'm going to go back to the PowerPoint slides. So I'm going to go back to the slides here and go ahead and show you some of this new functionality now back in SOLIDWORks. Alright, so some of you might recognize this assembly if you attended any of the What's New or the update training. And so I'm going to use this one here too. I'm going to zoom in so you can see the flanges here. So the new functionality, or the enhanced functionality on being able to auto size some of these flanges, I'll show you right away. So I'm going to go over to the design library, go into flanges, and here I have 3 different kinds of flanges here. I'm going to show you so you can see the different sizes here. So for example, if I put on one of these slip-on flanges, that's going to a 5-inch. Over here is a 2-inch, another 2-inch, and as soon as I place it, back in 2009 and 10, you'd see all these different configs, and you'd have to try to figure out which one would be the right one for you. In this case now, it shows up like this. NPS stands for nominal pipe size. So in this case, I'm just picking the schedule. It's already figured out it's a 5-inch. So I'll go ahead and select that. And now it's going to start the route. And you can see here, the new function here is use weld gaps. I'll go ahead and use that. And I'll put enough of a gap in here so that you can see it. It's 0.25 inches or about 6 millimeters. And so you can also see down at the bottom of these settings. Okay, that is in there. So you can see the weld gap stuck in there. And also on the bottom you see here it says automatically create fillets. So that means that when I start to create the route, I can just put in 90-degree bends, and it'll put the fillets in there. So for example, now I'll go ahead and run something in this case along the Z plane, and as soon as I get done, you'll see now it puts that bend in there. Now I'll go ahead and go over to another side here, and I'll go ahead and add another flange. In this case, I'll put in a 2-inch flange, and you can see now it's starting to make that side of the route. I'm in auto route, so I can still add pieces to it. You can see the bend in there now. Now, in this case, I know I have a 5-inch and a 2-inch. What I'm going to do now is I'll put in a reducer. And I'll go ahead and place it. And I'll place it right here on the end of this. Now again, the configs before, you would see a lot of different configurations. Now, in this case, it's picking the 5x2. And you can see now we're back on track. So it reduced it down. And you'll be able to see the pipe gaps, or the weld gaps here in a minute. I'm going to go ahead and run auto route. So here, piping, here's auto route. I'll select the 2 endpoints, and you'll be able to see the different ways I can run this. So I got it going through the rail, so I'll go ahead and pick the alternates. And let's see if I can get a good view so you can see it. So in this case, I'll probably have between 2 and 3 different solutions that might work, maybe even 4. This one's not too bad here. Maybe I'll use this one here. So maybe I'll go with this solution. So I'll go ahead and select OK, hit the green check box. Now I'm still in a 3D sketch. Now I'm going to go ahead and get all the way out of the sketch here because I want to show you the weld gaps. So now you can see I put the weld gaps big enough in here for you to see it. and I'll even close all the way out of the assembly. So you can see here's those gaps. Now a couple ways you can control them. I created the weld gaps when I first started the route, but at any time I can always go in here, edit the route. So now at any time I can go ahead and select one of these segments and go to weld gap, and then you'll see all the weld gaps come up. So I have some at 0.25. Maybe I'll make one a little bit bigger so you can see it. 0.5 inch. Maybe I'll make this one, make that one 0.1. And I'll go ahead and get all the way out of the route so you can see it. So that one's now 0.5. This one here is 0.1. So at any time I can come in here and change those sizes. And you can see over here those are still maintaining the quarter. And again, how I do that is I just click on it. I'm in edit route now so I can see the changes. Here's weld gap. So I can come in here and actually pick all these different ones. And I can always say override default, and I can set it back to 0 if I wanted to. And if I get all the way out of the route, you can see now the gap is gone there. Alright, so that's weld gaps, and it's up here too, up on the command manager. One of the other things I can do is this route along. So the other thing we have now is this thing called route along existing geometry. So let me show you that. So route along existing geometry. I'm going to go ahead and edit. In this case, I'll go ahead and edit the route. So you can always, smart dimension. I'll pick the line segment, and I'll pick the face here of the floor here of this structure, and maybe I'll make that 100. So that would be one way to put that in. Now the other way you can do it is you don't have to use smart dimension. You can just pick your segment, and then you just go ahead and select with control. So it's a control select. Now I can find over here where it says route along, and if I pick on that, now you'll see the dimension pop up, and that dimension shows up over here. I can move it where I want to. So now that's going to be tied to the floor there. So that again was route along. So it was a control select to get there. So the next thing I'm going to do is I'm going to go ahead and bring in a valve so I can show you the some other functionality that's available. I'll zoom in close so we can see this. So here's my valve. Now you might remember the tab button will flip this thing 90. The other thing that you can do is you can also use shift arrow, and the shift arrow is going to go ahead and give you increments of 15 degrees. Now once I get out of this, you can see the setting, the move triad setting didn't turn on, and that was one of the things I wanted to show you was move and rotate a fitting with the triad. So let's go back in here. So I'm going to go ahead and change that setting. So I'm going to go into Tools, Options, one way to get to the options. And I'm going to go to Routing. And here's one of the ones here I'll turn on the Use Centerline Dimensions too. But here's Use Triad to position and orient components. Some of you might like this. Some of you might use the Triad a lot to do move copy bodies and multi-body parts. In this case, we'll show you the functionality, and you can try it out and see if you like it. So save Triad to position and orient components. So now that I've turned that on, now let me bring that valve back in again. So the same functionality still works. The tab still works for 90. Shift left and right still rotates it. But now as soon as I place it, now the Triad comes up. Now the Triad comes up, and now I can move this around, and this thing will update. So I can move the location. But then also these circles, if you haven't used a Triad before, this will let you spin this 90 or 270, however you want to do it. And so that setting again here's a quicker way to get to options. Here, use Triad to position orient the component, and that's when you first drop it in. Now I can always right click now and say move fitting with Triad, so I can always spin that around, and maybe I'll move it back to 270. Alright, so that's the move fitting with Triad. Now the other thing I wanted to show you, and this is something I think that most of you will like and it's pretty handy, move and rotate fitting with the Triad, but also using the guidelines. So you can move a whole chunk of your pipes and in one of your routes, and then the guidelines are available for you to reroute the other things that are affected. So for example, maybe we want to move this away from the railing a little bit more. So where this valve is at, maybe I'll move it over a little bit too in the middle of this, and you'll see that it will update. So say we wanted to move this fitting, and so I'll right click on it, say move fitting with Triad, and let's say we want to move it a little bit towards me here, towards the screen. So I'm going to move this, and as soon as I move it, you're going to see these yellow dashed lines. They look like center lines. What I can do with these is I can, if I'm in auto route, with auto route turned on, here's these guidelines. Auto route, I can click on guidelines and then use these guidelines, convert guidelines to routes. The other way I can do it, which is a little bit faster, is I can just select one of the guidelines. I'll zoom in on this one, and I can just go ahead and say convert guidelines, and now my mouse shows up here on the screen, and if I right click, it's going to give me different options. So I'll go ahead and take the one where there's no custom bends here. They're all 90-degree bends. I'll right click to toggle, and then left click mouse to select it, and select the one that I want. I'll do the same thing again. Again, I can do show guidelines, and then also in this case convert them. So in this case, I'll just right click on it and say convert guidelines, and it's going to give me multiple options. I'll zoom in real tight so you can see this better. So now you can see in this case it's giving me a couple options, and then I click the one I want by just accepting it with the left mouse button click, and now there we go. So you can see now I move that, and I'll go ahead and get out of the sketch. So again, here you can see the there's the gaps for the weld gaps. You can see now what it looks like. So I move those and move the pipe over, put the elbows in there. So the guidelines really help me to move that quickly and make a design change quickly. Alright, so I don't think there's any questions, so we'll go ahead and show you now the piping and instrumentation diagram import and the reporting functionality. So the last thing I wanted to do before we went into CircuitWorks is show you a little bit of routing. In this case, again on the piping side, the piping and instrumentation diagram, the improved importing and the new reporting functionality. So the importing of piping and instrumentation data has been improved. You can now put in pipes that have inline fittings. As you are routing different systems, you can actually have a report, you can have a tree view or text view showing what has been connected, what still needs to be put together, and you can see it in green or red. Green means it's been complete, red it still needs to be finished up. So that validation report is something new for 2011, and the inline fittings is something new. So I'm going to show you a hot water system that'll show this. It has 5 different components and 3 different routes. So now I'm going to go into SOLIDWORks and show you that functionality. I already have an assembly with a base plate to represent basically the ground here. I have some coordinate systems already in place to speed this up, to just to quickly show you this, how to place these pieces of equipment. Now you'd have to have routing turned on, and over in the task pane on the bottom, the second from the bottom here is piping and instrumentation, and this stands for piping instrumentation diagram. This will help you to import, in this case, equipment and the routes. So I'm going to go and select import. It's going to ask me to pick what do I want to use for my XML file. In this case, I have a hot water system in this XML format. So I'm going to go ahead and say OK here, and it's going to have some other options. I'll go ahead and just select the default here. So now the first thing you'll notice on the right here is that it has the equipment. So there's 5 pieces of equipment, there's 4 tanks and a pump, and if I select, in this case, insert all equipment, what it's going to do is, you'll see on the left here, it's going to break down and show me all the different pieces of equipment. The first one is a pump, the second one is a tank. I'm going to go ahead and select the line axis, and when you select a line axis, that means make the front plane of the part coincident mated with the front plane of the assembly, right to right, top to top plane coincident mates. So that's what that align axis does. Here's tank 3. And then here's tank 4. Alright, so all of the equipment has been now placed. Now I'm going to go over to piping system, and now one of the things they've added, which is new for 2011, is this reporting functionality, and you can see it has 2 different options for the reporting. Here's a tree view. So the hot water route 1 has different pieces of equipment, including a valve. Here hot water 2 has, in this case, two lines or 2 pipes, and then mix 1 is the easiest one of the bunch to see, tank 3 connecting to tank 4. And I can look at this with a tree view or a text view. You can see it hasn't been started any of these routes yet, so we're going to start those up next. So the first thing I'll do is I'm going to select mix 1. It does show me this information over here, and you can see what it shows. And I'm going to go ahead and move this out of the way so I can see this a little bit better. And I'm going to go ahead and select mix 1, process pipe, and it's going to ask me in this case to pick my configuration, in this case schedule 40, and I'll turn off, in this case I'm going to turn off the coordinate systems. And you can see now this shows this guideline. It's almost like a guide curve. It's a guideline. It's showing the connection between tank 4 and tank 3. And now what I can do is just simply select, in this case, convert guidelines. And then you can see if I right click, I can get 3 or 4 different solutions. In this case, I'm going to go ahead and select this one, and how I select it and to confirm it is just click the left mouse button. Now I can still move this around a little bit if I want to and dimension it out. And now if I select OK here, you'll see now it's going to get me out of the route. I'll close this one all the way, and now what I can do is now I can see I got red here and green. Green means it's been completed, and I can always go to report, and I can see the green and red. If I go to text view, route 1 is complete. Route 2 and this route hot water 1 hasn't been started yet, so I can go ahead and close those out. And now I'm going to keep going. I'll get a good view here so we can see this real well. Alright, now I'll go to the next one. I'll go to hot water route 2. I click on process pipe, and now it's going to ask me, in this case, my options. Schedule 2, pipe is going to be 2-inch nominal, and then here's schedule 40. The elbow, I'm going to go ahead and leave the schedule 40 elbow in there. And once I select those configurations for the pipe and the elbows, now you can see again the guidelines. The guidelines show in yellow, and you can see it's basically connecting the dots here. Now once again, this is very easy. You don't have to go to show guidelines and auto route. You can just right click right on here and just say convert to guideline, and it's going to give you different options. So if I just right click, I got 1, 2, 3, 4. In this case I got 3 different options. I'll go ahead and select that one. To select it again, just click the left mouse button, and then do the same thing with the other guideline. Right click, go to convert guidelines, and now you can see I can right click until I see something that looks good to me and that's valid and not interfering with something else. Left click to accept it, get out of the sketch. So I get out of the sketch and I get all the way out of that subassembly, and now you can see I got 2 green and 1 red. If I wanted to show that in a report, I can go back and look. Here's the tree view again, and you see the red isn't completed. You can go to the text view. I got 2 that are complete, 1 that hasn't, and again this is that new reporting functionality I wanted to show. And then the last thing is going to be, we're going to have an inline fitting here. We're going to have a valve here, so I wanted to save this one for the last one. So here I go to hot water 1, and again how I start this whole routine here, or this step, is I go process pipe, and once I select that, it's going to take a second. It's going to ask me, in this case it's pulling information from that XML file. In this case the pipe thickness is going to be 2-inch, and then I could pick a different schedule if I wanted to. I'm going to keep with the same schedule 40. I'm going to go ahead and select OK here, and now what it's going to do is it's going to tell me, hey, you have in between tank 1 and the pump, you have a ball valve. And now where the heck do you want to put the ball valve? So you can see the stubs are there, and I can always just place it right in the middle, and that's what I'm going to do. I'm going to place it in the middle, and you can see the Triad. And if you haven't used the Triad much, if I want to rotate something, you can grab these circles, and I'm going to go ahead and make it, in this case, 270. And I can move it around with the arrows, and I'm going to just go ahead and leave it the way it is. I'll say OK over here, and now again I have the convert guidelines. I'll start with this top one here. I'll right click on it, go to convert guidelines, and then you can see it's going to again give me the different options. And so maybe I'll select that one there. Maybe I'll select that one. And now that one's done. Now the bottom one, this one might be a little bit more interesting. I'll right click here again, go to convert guidelines. You're only going to have a couple of options that are going to work so that they don't interfere. So I go right click, that one will work. That one's going to interfere on the bottom. That one interferes up here. So I have really, in this case, I think maybe 4 or 5 different solutions, but only 2 are going to work. So I'll go ahead and accept this one here, and then I'll get out of the sketch all the way. So in this case it let me put in the route with a valve in the middle here, and once this is done I'll get all the way out of the sketch. You can see everything is green. Again, the reporting functionality will help you to see that. Here is the tree view, and you can see that has that ball valve in there, that inline fitting, and then also I have the text view. It says everything's complete. I can print it. So that's some of the function I wanted to show you there. So now you can see that this route is complete. I can put some more dimensions in there, but you get the idea. So that was convert guidelines and show guidelines up there. Alright, so that's going to that's going to wrap it up for the piping side of routing. The next thing I will show you is CircuitWorks. Alright, so we're just about out of time, so I wanted to finish up the webcast with what's new in CircuitWorks for 2011. One of the big changes is SolidWorks has added user-defined coordinate systems for component orientation. When you have your component libraries, when you get vendor parts or parts off of 3D Content Central, or you make your own parts, they might come into CircuitWorks and SolidWorks and be built sideways. So there's now a way to fix that. So we'll be able to handle and control the orientation of your components. And then the component library interface has changed. You can import and export things now a little bit easier. And then the other thing you can do is you can compare the boards, and you can compare the shape and size and not just look at the component locations between two sets of models in CircuitWorks. So you can compare the shape and size now. And then finally, the export capability to a .asc format is now available, and the .asc format is for PADS Power PCB 2007 format. So what I'm going to show you first is this coordinate system. CWX can be used to orient the vendor part, and so a vendor part, again, or something you created or something that you got off of 3D Content Central. In this case, the XY plane will represent the board surface, and the positive Z direction is going to be perpendicular to the circuit board. The positive Z is going to be your up direction. So let me go ahead and show you the CWX coordinate system to help orient the parts now inside of SolidWorks. So now I'll show you some of this functionality in SolidWorks. So I've already turned on the add-in for CircuitWorks. I'm going to go ahead and open up an ECAD file. And this file is a .emn format. I'm going to open this up. And the component that I'm going to focus in on is a C10 component. And so I'm going to go ahead and select Build the Model. So it's going to build the assembly out of CircuitWorks and build a model into SolidWorks here. Now you see here's an option. CircuitWorks will fix the component in place. So what I'm going to do before I actually build this is I'm going to show you some of the options first. So here under CircuitWorks, here's one of the options. You have CircuitWorks options, and you'll see some of them are, here's one of them, import and export components relative to this coordinate system. That's the CWX coordinate system. That's going to be something that you could change the name, but the default is CWX. It looks at that, and the positive Z direction is going to be the up direction with respect to your circuit board. And then the other thing I did is for the import is I also set fixed components in place in SolidWorks. Now that's unchecked by default, so I usually check that so that the components don't move around by accident. When you just move your mouse, arbitrarily, you might move a component. So this might take a little bit longer. Some of you may experiment with that. Maybe you want to leave that turned off when you're first looking at a new design, and then maybe lock that down later. So those are two options again. Fixed component in place, and then here's that new one here, import export components relative to this coordinate system. So CWX. So I'm going to go ahead and open up the first example, and I can filter things and I can modify this a little bit, but in this case I'm just going to go ahead and build this, and I'm going to focus in on the C10 example. So I'll go ahead, and that's going to be the capacitor. Here again is the components fixed in place, and when I build this, I'll minimize the CircuitWorks window, and this is usually what some of you are used to seeing, is some of your components may be sitting sideways on the circuit board instead of face up and in the right orientation. So this component here is this Marconi component, and I'll look at it a couple different ways. I can open it up directly, or if I go into the component library, I could go to that one component too. And here it is. And I can always go and open the component, edit the component, and I'll go ahead and just open it from here, or I can always open it from directly. Now I did put in a little bit of geometry here to get this orientation correct. I'm going to go back to the slides in a second. But first, what I'm going to do is show you the capability of creating a coordinate system. So in this case, if I go over to Features, Reference Geometry, here's Coordinate System, or if you don't use the Command Manager, Insert, Reference Geometry, Coordinate System. And so now I'm going to select a point here. I've added a point. Here's going to be my x-axis. This one's going to be my y-axis. And I just have to flip the orientation. So here's my x and y. Here's z going up. It's going to be a little bit hard to see, but z is going up towards the top of the screen. And here's x coming in this direction, and y is going away from the screen here, going into the screen. So I'm going to go ahead and say OK. That's just going to be called Coordinate System 1. So I can either slow double click or hit F2, and I'll call it CWX and capitalize that. I'm going to save this part. And once I save this part, now I'm going to go ahead and close out this model, this new assembly, and now I'm going to go ahead and re-import this. So again, CircuitWorks, open CAD file, and there are some examples. This is one of the examples that comes with SolidWorks. So I'm going to go ahead and open up this assembly again, or in this case, CircuitWorks. And so everything's going to look the same here. So here's example 1, and you can see here C10 again. And from this view, you can't tell, how the model is going to look. But once I click on Build Model, now you'll see it's telling me what's going on. There's a couple files that will just be 2D sketches because they don't have a height. You can fix that if you wanted to. Where those show up are where these warning signs are. I'll go ahead and leave those alone for now. Now I'm going to let it build the model. And once it's done building the model, now you can see this is oriented correctly. If I go back to the slides, here positive Z direction is the up direction. It's going to be perpendicular to the circuit board. I tried to make this so you can see it better. Here's the Z direction going up, and you can see X and Y are going to represent the board surface. And so now if I go back to here, let's go back to the assembly. And now if I ever want to view the coordinate systems, I just go View, and here's Coordinate Systems. And what I'll do is maybe I'll make this part transparent so you can see that Z direction is going up, and this is the one that I modified here. So Z is going up. So CWX is the coordinate system that they defaulted. You can always change that. Again, it's under CircuitWorks options, and here is export and import relative to CWX. So that's one of the big changes that might help a lot of you if you guys bring in stuff from 3D Content Central, or make your own parts, or use the vendor ones. So that's one part of what was modified. The other thing was the component library interface improvements. I'll just quickly touch on that. So here under Tools, here's Import from Text File, or Import from a database, or you can export to a text file and read those back in. So these are going to be things that you can use to import or export these component library files to other computers if you wanted to. So those are some of the other things that have changed between 2010 and 2011. So I just wanted to point those out to you. The next thing I'm going to be showing you is the compare command. Now identifies differences in the boards, the circuit boards themselves, the shapes of them, not just the location of the components. Let me go into SOLIDWORks and show you that functionality now. Here's the assembly that I had opened up and imported in from CircuitWorks into SOLIDWORks. And what I'm going to do is I'm going to change the circuit board layout so you can see that compare command in action. So I'm going to go into the board outline. I'm going to edit this sketch. It's going to want me to save. I'm going to go ahead and save the assembly. I'll go ahead and make a few minor modifications here to the, in this case, the board outline sketch. So I'm going to go ahead and move some of the geometry slightly and make a few noticeable differences. And so I'm moving the board outline here. So this is the board outline, and if I wanted to, I could change the, in this case, the route outline too if I wanted to. So I'll go ahead and make them match up. And I'll show a couple of minor changes with some of the capacitors. Here's the capacitor I was working on before. I'm going to change it by right-clicking it, making it float. And here's something that some of you might not have used before, and this is called Move with Triad. And I was showing a little bit of this before on the routing side of things. So I'm going to move this a little bit and not actually move it off of the circuit board. And same thing over here. I'm going to right-click, go to Float, and I can go to Move with Triad, and I'll move this one down into the side a little bit, so you can see the other functionality of the compare command. Alright, so now I'm going to save this out. I'm going to say File, Save As. I'm going to rename this, and it's going to have me save everything, so I'll save everything here. Now once it's saved, I'm going to go back to CircuitWorks. I'm going to go and export this back to CircuitWorks because I want to show you the compare tool. Now here is the original one. The original file that I opened up was the one here on the right, the example 1. And then the one I just modified is over here, mod 1. Now what I can do is I can use the compare command. So if I select it, it's going to tell me what's changed. And in the past, you wouldn't be able to notice a circuit board shape change. Now you can see it. So you can see here it says board shape changed. And the other things that were there before, I just want to show you that that functionality is still there. As you can see how it compares the capacitor I moved, and then also the other one I moved here. And you can actually right click on them and you can move those around. The shape you can't change it back, but it does, at least in this case, tell you the differences there. With the capacitors, if you did want to move them back, you can move them with respect to the original, or move the original to the new change that you just made. And so if I update this one, I can maybe move the C10 one. I'll move that one back into place. So I right click on it, and then I can go ahead and change it. and you can see now it just moved over. So you can still see it still highlights the other one, and you can still see that it shows the board shape had changed. And you can see it because I lengthened it up here, and I changed the angle of this this angled cut here. So that's the difference between this and 2010, is that now you can at least recognize that there is some changes with the circuit board shape. Alright, so the last thing I'm going to show you is the saving out with that new format. So the new format is export to pads power PCB 2007, the .asc format. So now I can show you how to export into that new format. We'll go ahead and close this one out. This was the original. Here's the one that I did the few modifications on. And now if I go over to the save button, and if I hit save, you'll see that here is that new format, that .asc format. Here it is. And if I want to, I can save it in that format now. Alright, so that was saved. Alright, so that's going to wrap it up here. There's no questions. So once again, thank you for attending this webcast. If you have any questions, you can call us at 800-575-7543, or you can email us at support@ddicad.com. You can, if anybody's interested in getting the PowerPoint slides, you can just email us at support@ddicad.com. Thanks again for attending, and I'm your host again, Maurice Cherian. Thank you very much.